This is video lecture for week 10. In this video lecture, we complete the application of differentiation with the examples on optimization and related rates. Let's take some examples on optimization. Suppose you have a 40 feet of fencing with which to enclose a rectangular space for a garden. Find the largest area that can be enclosed with this much fencing and the dimension of the corresponding garden. First, note that there are lots of possibilities which is shown here. We could enclose a plot that is very long but narrow and one that is very wide but not very long. So these are the things. First, let us draw a picture and label the length and the width. Length denoted by x, width denoted by y. So this x and y are the dimension of the garden. Here we show here the length and the width. What is the area of the rectangle? Length into width, that is x into y. Area is equal to x into y. So we have two variables, so which is very difficult to solve. So what we will do, we will find the y in terms of x, and for that we use this information that 40 feet of fencing is the total. That means the addition of the entire this boundary is 40 feet, so which is known as perimeter of the rectangle. The perimeter of the rectangle is given by the formula 2x plus 2y is the perimeter, which is equal to 40. Find y in terms of x, which is this. Substitute y here. We have a equal to xy is this. Take x multiplies, then we have this. Now we have to maximize this, that is ax is equal to x times 20 minus x. So we find the derivative, then equate to 0. Solve it, you get a critical number. Linear, you get only one critical number, x is equal to 10. So we have what you call end points. So we have end points 0 and 20. Find the value of a at end point, that is a of 0 which is 0, a of 20 which is 0, and then find the value of a at this critical point which is 100. Compare these three values. This is the maximum. So therefore the maximum area that can be enclosed with 40 feet of fencing is 100 feet square. The dimension of the plot are given by x is the length 10 and y is 20 minus x. Substitute here, you get 10. So x is 10, y is 10, therefore it is a square. Let's take one more example. A square sheet of cardboard 18 inch on a side is made into an open box. You see, there is a cardboard sheet of cardboard which is a square with 18 inch is open, and note that there is no top. By cutting the squares of equal size out of which corner, each corner, and folding up the sides along the dotted line, you see the figure next slide. Find the dimension of the box with the maximum value. Here we have a picture. So the box open and it is open here, and the height of this is x, right, and the total length is 18, and when you open it, here x, that is 2x. So 18 minus 2x is the dimension of that is length, and this is a square, therefore length and the width will be the same. So therefore the volume of a rectangular parallelepiped is L into W into H. So H is given X and L and W are same because it's the square. So it is 18 minus 2x. I substitute here. So V equal to this. You multiply. And we have finally V of X is this. And what are the interval for this? It is 0 to 9 because we will be taking in the closed interval here, that is 0 to 9 are the what you call interval where this Px is there. Then what we do? We find the critical number, we find the derivative and using the product rule, and then we have this equate to 0, solve, you get two critical number, quadratic you get, so 3 and 9. So this 3, 9 and this 0 and 9, that which are the end points, to substitute here in V. So we get V of 0 is 0, V of 9 is 0 and V of 3 is 32. So this is the maximum. Therefore the maximum possible volume is 432 cubic inches. So that cubic inches is the answer for this question. Let's take some examples on related rates. Here we have an oil tanker has an accident and oil pours out at the rate of 150 gallons per minute. Suppose that the oil spreads into the water in a circle at a thickness of 1 by 10 inch. Note that 1 feet cube equals to 7.5 gallons. Determine the rate at which the radius of the spill is increasing when the radius reaches 500 feet. So the rate means derivatives. Area of the circle pi r square and the volume will be depth into area. So area is pi r square. The depth which is 1 by 10 inch, right? So that we converted into feet. So it is 1 by 120 feet. So depth is 1 by 120. So both volume radius are the function of t. So therefore V of t, this r is also function of t. Then we differentiate both sides with respect to t. Then it is V prime t pi by 120, that is RT square. Here we use the chain rule 2r, then the derivative of r prime. So the volume increases at the rate of 150 gallons per minute. So convert this into feet. So 150 by 7.5, 20 feet cube per minute, because 1 feet equal to 7.5 gallons. Substitute. So V prime t, which is given as 20. Yes, here we are given volume increases, and then r is equal to 500, which is given here radius, which is 500. Substituting this, so r is equal to 500, V prime t equal to 20. Substitute here, then we can find r prime t, which is nothing but rate. So when we solve it, we get 2.4 divided by pi. Then we have another example of a sliding ladder. Suppose we have a 10 feet ladder leans against the side of the building. See, this is the 10 feet ladder is leaning to the side of the building. If top of the ladder begins to slide down, that is, it is going down at the rate of 2 feet per second, how fast is the bottom of the ladder sliding away from the wall? That means this part. When the top of the ladder is 8 feet off the ground, that means when the height of where it comes down here, so the distance from here to here, it is 8 feet. So what we do, we sketch it first diagram. So since the ladder is sliding down the wall at the rate of 2 feet per second, so it is dy by dt is equal to -2. So here we say that we are denoting the height of the top of the ladder as y and the distance from the wall to the bottom is as x. So by Pythagoras theorem, because it is a right angle triangle, so x square y square equal to 100, that is adjacent opposite is equal to hypotenuse. Find the differentiation both the sides. I mean differentiate both the sides with respect to t. So this is 0. So we differentiate this using the chain rule, 2 x prime 2 y prime, then solve for x prime. So we have this. So since the height above the ground of the top of the ladder at the point in question is 8 feet and means y equal to 8. Substitute here in the Pythagoras theorem, we get x square and we can find x, which is 6. Now we have x prime t is equal to minus yt upon xt into y prime t. So yt is given, xt is given, y prime is here, this is dy by dt equal to -2 which is given, so that means y prime t, substitute here, you get this answer. We will consider some more examples in the next part of this video. Thank you.